కేస్ వర్క్ కాదు.
Sharpada ma'am, can you play the video? The video is not being played. Good evening, dear participants. We will wait for a few more minutes for our HOD and principals to join with us. We'll start the session in a few minutes. We'll wait for a few more minutes. We'll wait for a few more minutes. We'll wait for a few more minutes.
who is always a source of inspiration and pillar of support for all our activities. Welcome you, sir. Thank you for joining. In spite of your busy schedule, sir, you have meetings. Thank you for joining.
Thank you, sir. Thank you very much, sir.
Who is
Thank
always
you.
a source of inspiration and pillar of support. I would like to, for all our activities, warm welcome to the guest. Welcome you, sir, and thank you for joining, Dr. In spite of your busy schedule, sir, you have meetings. Faculty, senior lecturer, faculty
Thank you,
of
sir.
mechanical and
Thank you very much, sir.
who is
Thank
always
you.
a source of University inspiration and pillar of Malaysia for all our activities. Warm welcome you, sir. The thank you for welcome you, sir, and thank you for joining, Dr.
Thank you, sir. Thank you.
busy schedule, sir. You have faculty. Next, I would like to extend a warm welcome to
Thank you very much, sir.
who is
Thank
always
you.
head of the department, faculty members, from Malaysia for all our activities. Warm welcome you, sir. The various welcome you, sir, and thank you for joining the country.
Thank you, sir. Thank you.
I think few participants are also. Next, I would like to extend a warm welcome to other country. So my warm head of the department, all the faculty members from Malaysia. I would like to extend my best welcome you, sir. The coordinators, welcome you, sir, for selecting this country.
Thank you, sir. Thank you.
For I think 1 week of international activities. A warm welcome to other country. To mention last year also we have conducted all the faculty members Synthetized program for all of them. Welcome you, sir. The coordinators, welcome you, sir, for selecting the country.
Thank you, sir. Thank you.
I think I take one special once again. To mention board. To mention last year also we have conducted all the faculty members as well as the speaker for all the department of welcome you, sir. The coordinators, welcome you, sir, for national board of education.
Thank you, sir.
It is valid till 2006. I take one special once again. To mention we also have a center of mention last year of renewable energy research. Lots of research activities are being carried out. We have done the consultancy project by national board of education.
Thank you, sir.
It is valid. We have few clubs. One special once again. Electronics. We also have a center of mention last year of renewable energy research. Lots of research activities are being carried out. All these clubs are very active in the department. Lot of activities are being conducted every week, and certifications are also provided. Lot of new softwares are being taught from the department, and we have state-of-art laboratories. To mention, we have a high voltage transformer of about 100 kilovolt, which is a very unique facility in the institutions, especially in the self-financing institutions. Only it is found in few IITs and universities. And at this juncture, I also invite the faculty members from different institutions. You can also take part in our research activities. Lot of research is also being carried out in that field. And we also have a state-of-art laboratory in renewable energy. We have recently set up a renewable energy laboratory worth rupees 20 lakhs, and that can also be best used. We conduct lot of activities and research programs also being offered. So these are some of the highlights. Our students take part in lot of competitions. It is a very important feather, actually started by our principal, sir, in the name of pride. Maybe he will explain it in detail when he is giving his session. So students have participated in International Innovation Future Prototype Challenge conducted by SMIT, and they have won the 3rd place, and also their project was accepted for startup grant. And besides, one batch have participated in the ideation challenge. They have won the 1st place. A student have developed drones for industries. It has been accepted by industry, and it will be used for the construction sites. Similarly, lot of achievements are also made by the students. And also in the sports and other activities, our student has won gold medal in the state level weightlifting competition conducted by the state government. It is won by the 1st year student. So a lot of achievements are there from our side. So just these are some of the highlights I would like to inform all the members who have joined here for this in this virtual meeting. So with these few words, I would like to once again extend my warm welcome to all the participants who have joined. Thank you so much. Thank you, madam.
Thank you, sir. Thank you for a warm welcome. There is a great power when a group of people with similar interests get together to work towards the same goal. We have gathered here for one such program. May I now invite our coordinator of the program, Dr. P. Marish Kumar, Associate Professor, EEE Department, to brief about the program.
Good evening all. A warm welcome to one and all present here. I am delighted to give the overview of the International Faculty Development Program organized by Department of EEE of Eastern Engineering College. Respected Principal, Vice Principal, Head of Departments, esteemed colleagues, and learned faculty members, I wholeheartedly welcome you all to the inaugural function of International Faculty Development Program on Research, Innovations, and Emerging Advances in Electrical Engineering. I would like to acknowledge Eastern Engineering College for this excellent opportunity given to us. The convener of the program is Dr. E. Kaliappan, Professor Head, Electrical and Electronics Department, and the coordinates of the program are myself, I am Dr. Marish Kumar, Associate Professor, EEE Department, Dr. Karpagam, Associate Professor, EEE Department, Mrs. Sindhu Sailaja, Assistant Professor, EEE Department, and Lydia, Assistant Professor, EEE Department. This FTP focuses on the various innovation and current trends in the field of electrical engineering. A 6-day online International Faculty Development Program is conducted from 14/6/21 to 19/6/21. Day 1, today the session is on the topic Recent Advances in Floating Solar PV System by Dr. K. Sudhakar, PhD, Research Fellow, Senior Lecturer, Faculty of Mechanical and Automobile Engineering Technology, University Malaysia Bahang, Malaysia. On day 2, the topic is Efficient Techniques for Mitigation of Partial Shading, will be delivered by Dr. T. Sudhakar, Senior Member IEEE, Research Fellow, Institute of Power Engineering, University Tenaga Nasional, Malaysia. On day 3, the topic is Application of Power Electronics and Machine Learning to Renewable Energy, will be delivered by Mr. Sivaguru Paramasivan, expert in renewable and energy storage systems, Abu Dhabi Future Energy, Abu Dhabi, UAE. On day 4, the title Art of Writing the Research Paper will be delivered by Mrs. Vishnupriya Balasundaram, Learning Resource Assistant, Anglia-Russia University, London, England. On day 5, the title Subsea Power Cable Installation in Oil and Gas Industry will be delivered by Mr. Charge Baby, Operational Engineer, Saipam, Sharjah, UAE. On day 6, the title Renewable Hydrogen Energy System for an Isolated Microgrid will be delivered by Mr. Muhammad Alamgir Hussain, Postdoctorate Research Fellow, Queensland Micro and Nanotechnology Center, Griffith University, Nathan, Australia. We had received overwhelming response, nearly 750 registrations, which includes participants from various parts of the country and abroad. The participants are requested to attend all the sessions and get benefited. E-certificate will be provided for participants under successful completion of the program. I firmly believe that this International Faculty Development Program will serve as a great platform for the academicians, research scholars, and industry persons to upgrade and refresh their knowledge in the area of research innovations and the emerging technologies of electrical engineering. With this note, I would like to welcome all the expert members and the participants to this program. Thank you.
Thank you, sir, for giving us an insight of the program. A person of high spirits and motivation, and who never ceases to charm us with a great energy. I now request our most respected Principal, sir, Dr. R.S. Kumar, to give the presidential address.
Thank you, Madam, and thank you, HOD EEE, for giving me this opportunity. This is an amazing lineup of experts, all in highly relevant fields. Okay, today's topic is I think the hottest topic now. Every country is looking at the floating solar PV plants. So because space is a constraint and in sea you can always have it. So these are all latest trends, and of course Malaysia has done some wonders in this already. They've got big plants already generating electricity. So it's very nice to have a guest who is an expert in this field. Thank you, Dr. Sudhakar. Thank you for being with us today. Thank you so much. So are the topics, the other topics as well over the week. I'm sure there's a lot of knowledge sharing and overall discussion pertaining to improvement and implementing new things at our place. All these things will definitely happen. Ideas will be born, ideations will be done. These are all very nice topics, very important and relevant topics. My congratulations to you, sir, HOD sir, and to your dynamic team. We have got a very efficient team who is working day and night to make all these activities a grand success. You mentioned about the infrastructure. Yes, EEE today has some of the best infrastructure available related to all kind of research activities. So, and you have invited other college faculty members. Yes, I fully agree with the HOD. We cordially invite you to visit our place and also see how you can utilize the infrastructure. Ishwari is an autonomous institution, so we frame our curriculum and we frame our regulations, syllabus, everything. We conduct our examinations. Of course, there are strict quality assurance methods which we are following. The curriculum syllabus is one end is at the fully student oriented and the other end it is fully industry oriented. So we are looking at an industry come student oriented regulations and curriculum, internships, projects at industries, joint projects with industries, joint projects with institutions of repute. All these things are happening. So many other institutions who wish to join hands with us for research projects, you are most welcome. We like to call you, request you for joining with us for research activities, for better academic activities. And sir mentioned about PRIDE. PRIDE is acronym for projects, research, internships, design, and entrepreneurship. So these are the 5 activities we are requesting our students to be fully involved and the faculty to support these kind of activities. So last year alone, we have more than 428 winnings, 488 awards. So, and more than 4,000 students participated in many of these events. Texas Instruments rated us as a star institute. We had more than 1,700 entries. So all these are possible because of our faculty members who are fully guiding, motivating, and contributing towards the success of all the students. So I want to thank our faculty members. And this time, as many of you know, we have got great admissions also. Last year also we had great admissions. So EEE is doing very well. It's become an interdisciplinary area. And henceforth, somebody says automobile engineering, I think he or she will be 50% electrical engineering. So that is how life has changed suddenly, and that is how renewable energy is now getting more and more EEE oriented. So these are all good tidings. Okay. So I once again cordially welcome all the participants. Thank our expert speaker today, Dr. Sudhakar, and congratulate all our EEE dynamic team members. Thank you so much. Jai Hind, Namaskar.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Please go ahead, madam. Thank you.
Yes, sir. Thank you, sir. So now we have reached the most important part of our session. So our session is going to start. Now I request Mrs. J. Lydia, Assistant Professor, EEE Department, to introduce our distinguished speaker of today's session, Dr. K. Sudhakar, Research Fellow and Senior Lecturer, University of Malaysia, Pahang.
Thank you, ma'am. It's my pleasure to introduce the speaker for the session. Dr. K. Sudhakar is an Indian living and working in Malaysia and blending the best of both cultures into his life. Currently, he is a research fellow, senior lecturer at the Faculty of Mechanical and Automotive Engineering Technology, University Malaysia, Pahang. He has been on long-term leave from his permanent position at MANIT Bhopal. He is also serving as visiting faculty, researcher at several other universities in Lithuania, China, Indonesia, Russia, and Vietnam. He obtained his BE in Mechanical Engineering from Government College of Engineering, Salem, Madras University in 2001 and MTech in Energy Management from School of Energy and Environment Studies, Devi Ahilya University, Indore, 2006. He obtained his PhD from the National Institute of Technology, Tiruchirappalli, in the year 2013. His primary research areas include heat transfer in energy applications, energy analysis, energy conservation, micro and macro algae-based carbon sequestration, biofuel, solar thermal and PV systems, hybrid electric vehicles, energy modeling, food, water, energy nexus. He has published around 150 research papers on renewable energy, alternative fuels, microalgae biomass, RE policy, and resource recovery in SEI Scopus indexed international journals and conference proceedings. He has authored more than 10 technical books. He is a cited energy manager and auditor by Bureau of Energy Efficiency, Ministry of Power, Government of India. His research work is cited more than 4,800 times in peer-reviewed journals with a total impact factor of more than 150 and an H index of 40. Dr. K. Sudhakar is ranked among the top 2% scientists worldwide by Stanford University, USA in the field of energy. Dr. Sudhakar has received several awards and honors in his career. He has received the Excellent Researcher Award for consecutive years, that is 2018, 19, and 20 at University Malaysia, Pahang for his outstanding academic achievements. He has played the editorial roles in many and acted as an active peer reviewer of 75 scientific journals, to name a few: Elsevier, Springer, Wiley, and Taylor and Francis, indexed in WS and Scopus. He is also the guest editor in several special issues of the MDPI, Hindawi, Tech Science, Frontiers, etc. And to just mention about the few outreach and other activities, he has delivered over 50 invited talks in various national and international forums. He has also delivered invited lectures in India as well as abroad. So we are very delighted to have you, sir. I warmly welcome you, sir, to our session.
Okay, thank you, ma'am. Thank you, the organizers, for giving me this opportunity to be here for presenting this small introductory topic on floating solar system among all the participants. It seems today we have a full house. I don't know how much I will justify this program. I hope I'll try my best to present something useful for all of you, so that we can take this research forward and contribute something to the world at large. Okay, let me share my presentation. I hope it's the slide is visible.
Yes, sir.
Okay. Very good evening to all the participants, which has helped a lot in linking us together in this digital forum. Mostly we are all talking in terms of virtual collaboration, virtual mobility, and these days actually not go and talk personally, deliver a talk personally. It has become a norm that virtual mobility, virtual exchange has taken place. So this international event has opened such opportunities to collaborate, especially with universities, with engineering colleges, with reputed universities worldwide. So I'm very thankful to both my organization, University Malaysia Pahang, as well as my the university which has invited me, the SRM, the Ishwari Engineering College, and the entire management of Ishwari Engineering College for giving me this wonderful opportunity. At the same time, the success of any program depends on the participants, I'm very happy that many of you have joined for this program. It's a huge support for this event, and I'm very thankful. I don't have words to express that you are all keen to listen to my talk, and I'm very privileged. I'm very privileged to be part of this event. So coming to the topic of my presentation is about some recent advancements in floating solar PV system, which actually currently the hot topic in the field of renewable energy, as principals are also highlighted about how the solar or renewable energy is playing a very important role in the energy mix of the country, especially the Asian countries is actually facing a severe crisis in terms of energy, in terms of water, in terms of land. All these issues are very much hot in the area of Southeast Asian countries. Let it be Malaysia, let it be Singapore, or let it be Thailand or other Southeast Asian countries, or maybe our own India or Pakistan or Bangladesh or Sri Lanka, or let it be Asian countries as a whole. There is some important challenges which actually these Asian countries are facing. However, the European countries and developed nations are all actually at a better position than us. And that needs some kind of innovative solutions to address so many challenges what the humanity is facing. Let us see the challenges first, and then how this technology can fit into it, and then what are the problems we are currently facing when related to the PV technology, also the floating technology, and how as a researchers we all can contribute to the development of the technology as a whole. That is how I have structured my presentation. I see there is a lot of undergraduate students or maybe the experts also join, but I give only an overview. I hope this will give some idea about the technology as a whole, and then what kind of advancement is further needed in order to improve the technology solution. So that is what I want to present it today. Coming to the introduction part of this, you all know that the Earth's surface, I think 3/4 of the Earth's surface is covered with water. We are living only 1/4 of the land surface. So 1/4 of the land is very limited, especially for a country like India, which is very densely populated. We need a lot of land for many other purposes, for agriculture, for education institutions, for commercial purpose, for consider the land as precious resource. Land has become very expensive also these days. Even we ourselves cannot afford a land. Even a small land we want to acquire, it is very difficult. So this is a major problem. So we are actually living in water. 3/4 of the land, the water, 3/4 of the Earth's surface is actually with water only. And enough sunshine hits the Earth's surface with zero shading effect. Almost the whole country, the Asia as well as the Indian scenario, actually you can see there is a very good amount of sunlight available, even on the water bodies or on the Earth's surface. Wherever you go, there is a good amount of water present available, enough sunshine available, and the energy consumption actually is going to increase a lot. Roughly, they predict around 50% it is going to increase, and there will be a tremendous demand of water consumption, because you know many of our energy systems also uses our fossil fuel thermal power plant is actually using water for its producing steam, and then the steam is used for running the turbine. So in that case, energy is being actually used for power generation. You take an example of hydrothermal power plant, also water plays an important role. The same way it goes to the thermal power plant, water plays an important role. So we are putting lot of thrust on these two things actually. A lot of pressure on the water surface, water bodies, lot of pressure on the land bodies. All these things are also getting pressurized. So we are indirectly creating an unsustainable environment by putting too much pressure on water, too much pressure on the land actually. So this is one challenge we are facing. And 50% of the global withdrawal caters to the energy production. So whatever we are extracting water from the Earth's surface, it's to the production, especially conventional based power generation and all, is taken from the freshwater bodies. The same holds good. Hydropower, roughly they say 25% of the world's energy is coming from the hydropower. And this has remained stable since 1990s. There is no much major change in the hydropower supplies. And also this hydropower, there is a very less efficiency also. The capacity utilization factor in the case of a drought season, when there is no rainfall, the CUF, the capacity factor of the hydropower plant comes down also. This is a major problem with the hydropower. And also, most of the water bodies in India, especially in summer seasons, for example, in April, in March, or maybe in June, July, we face a lot of problems, especially Chennai and big cities. They face a lot of water shortages also. And many of the water problem is there in agriculture. Tanjore district in our country face a very big problem because it depends on paddy cultivation and all these things. So fresh water is very much needed. And also there is a lot of land and water conflict with the neighboring states. You take Kerala, take Karnataka, or take Tamil Nadu, with all the South Indian context, we have small problems with our neighborhoods, which should have been addressed. But unfortunately, this is due to the land and water resource, which actually creates a lot of conflict. So somehow or other, we need to overcome all these conflicts by providing a sustainable solution. In that way, only we can address these all challenges. Further, land constraint is a big issue because ultimately we need agriculture. Food is a major thing. Then comes the land for energy. Then comes land for other development activities. So food is very important. Water is very important. And sustainable use of the resources is very important. So these are the challenges. And for addressing all these challenges, we need to come up with an innovative, viable solution which can solve all these problems as a whole. For that, about sustainable development goals. I think it's a very important aspect which everybody should understand. What is sustainable development goals, which talks about no poverty, zero hunger, good health and well-being for all, quality education for all, gender equality. It talks about clean water and sanitation, affordable and clean energy for all, and economic growth of the country. It includes industry innovations. It includes reduced inequalities. This is one important one. Sustainable cities and communities. So these days, actually, urban cities have grown like very much unsustainable way. So people are now moving back from the cities to the villages or towns, actually. So this kind of movements also happening. So in future, we need to think about developing cities which are actually sustainable, which are very smart. So this is one of the sustainable development goal. At the same time, should be a responsible consumption and production. So whatever we produce, whatever we use should be responsible. It should not create any impact on the environment. It should be sustainable in the long run. So this is also one of the important goals. Likewise, we have several sustainable goals. And coming to this topic, using this technology, we are going to address two important goals of that. What is called sustainable utilization of land and water resources. That is sustainable consumption and production, which will be goal number 12. And then affordable, reliable, and sustainable and clean energy for all, which will be our goal number 7. So basically, with this floating solar technology, we can address at least 2 sustainable goals. There are, of course, other goals also indirectly comes into picture. So with this, 2 important sustainable goals can be addressed. Let me give into some small introduction about the types of solar installation. I'm not going into the basics of solar PV systems. So I hope all of you understand the PV technology. PV technology is the one which uses sunlight energy to convert into electricity with the help of photovoltaic effect. And the solar PV is very easiest and simplest of all technologies, because the thermal technology, CSP, is very complicated. It involves so much other extra components. It involves water usage and all these things. So therefore, the PV technology has become very easier than the concentrated solar. But the way of installations, actually, there are different ways. Let us go into the concepts one by one. One is rooftop-based solar installation, which is installing the solar PV on our buildings, actually. This is one way. Other way is installing the solar on the ground system. Again, when we use the ground, then the land conflict is coming. So when we talk about solar farms, solar park, then we talk in terms of utilizing large amount of land, and this will create actually a lot of impact. So slowly we are moving away from the ground mounted system. And then there is a canal top solar installation also. Canal top is installing the solar PV on the canals. India is famous for rivers. India is famous for so many irrigation canals and all these things are there. So canal top is becoming popular. And the last one will be our floating solar installation, where we'll be installing solar on the water bodies, let it be lakes, rivers, it might be dams or any other water reservoirs where we can install solar systems. So these are basically 4 categories. But all these 4 categories, each technology has got its own drawback. Actually, each method of installation has got its own drawback. Let me go into the detail one by one. Coming to the roof-mounted system, this is a very simplest one and it's very sustainable. But again, in the case of roof-mounted system, the problem here is with the heat transfer. I'll talk in terms of a little bit about thermal aspect also. It's because you need to understand that the solar PV system is basically a device which is converting sunlight into electricity. Sunlight is nothing but the heat energy. It is basically solar energy is giving photons which contains some thermal energy which is in the form of heat. And this is getting converted into electricity, basically through photovoltaic effect. But what happens in the roof-mounted system, when the solar systems are directly connected, installed in the building, there is a small amount of air gap between the building and the roof. And this small air gap actually creates less amount of convection. The heat transfer due to convection will be less. And because of that, there will be more of heating effect. More of the heating effect means then there will be less efficiency. So basically, when you compare the roof-mounted system and the ground-mounted system, the less efficiency will be this one. Less efficient because there will be less amount of heat removal from this. Basically, we want to remove the heat from the system. The solar PV systems only produces 15 to 20% of the sunlight into electricity. What happens to the 80% of the energy? 80% we are actually producing heat. And this heat actually, if it is not removed from the system, it is going to cause a drop in the efficiency. And if this drop is there, and then naturally the life of the solar panel and the life of the entire system will decrease, and then the system will fail very quickly. So this is a problem with the roof-mounted system because of the heat transfer loss, or you can say the heat loss due to convection will be very less in this case. Whereas you see the ground-mounted system, you can see the enough air gap is here. If wind flows here, the wind can take good amount of heat from this. So whatever heat which is flowing on the front side and whatever heat coming on the back side of the panel can be removed by natural convection. So thereby, in ground-mounted system, the efficiency is much better than the roof-mounted system. But again, the pros and cons are, this will occupy the land, it will put a lot of land footprint. But this one is land neutral, so it is very beneficial in terms of saving our precious land. It leads to decentralized power generation. It contributes to the better way of energy utilization. But it comes at the loss of efficiency and loss of power. So this is a major problem with the roof-mounted system. And again, if you see in Malaysia, we have this kind of roofing. Actually, why? Because Kerala and Malaysia, the climatic conditions are tropical. In tropical regions, actually a lot of rain also coming here. So because of the rain factor, the roof will be something like this. The roof of the building will be like this because the water should fall and gets collected easily. But if you have a flat roof, actually water gets accumulated. So wherever the location is having a lot of rainfall, the roof will be like this. It will be an inclined roof. It will not be an open roof like in our case of Tamil Nadu. Many of the houses will have a roof which is flat because this is due to the fact of rainfall only, and depends on the local climatic condition and local how people develop the buildings actually. So this kind of slanted roof systems are there, and here you can see there is no air gap between the building and the solar panel. When there is no air gap between this one, it leads to more of heat energy accumulation. A lot of heat energy getting accumulated, it is going to affect the performance actually. And coming to the ground-mounted system, there can be a tracking-based system. Why? Because the solar PV system, when it is fixed at a particular angle, facing the south at a particular angle, it gives less amount of energy. So basically, with the tracking system, when the system is able to track the sun with different seasons or different months, we are able to enhance the performance. Again, the problem with the tracking is it's all electronic systems, which involves a lot of investment. Even fixed solar system itself, a very expensive technology. And when you add the electronic components into it, all the servo motors and all the complex mechanism into the system, it will actually add to the overall cost of the system. So thereby, the tracking system is not that popular, but manual tracking is happening in many of the PV plants in India. They go for manual tracking. the whole array is actually tracked every month or every seasons. They change the angle and they try to enhance the performance of the solar plant. So this is how they are managing the improvement in the efficiency with respect to the land-based plants. Coming to the canal top plants, you can see here the canals, the water canals can be used for covering with the solar panels. The only problem with the canal top will be the metallic structure actually, because this metallic structure is very expensive. We use a steel metallic structure. And in case if your canals are not narrow, it's not like this straight, and if it is zigzag, let's say it's zigzag like this. So if it is zigzag, what happens? Your metallic structure and all these things will be very complex in design. So we cannot have this kind of arrangement for a canals which are actually bending and the canals which are not very straight. But canals which are very straight, for this it's possible. But again, lot of material, and these materials actually add to the cost. Steel production is not that easy. Steel energy, the steel production process consumes a lot of energy. It consumes a lot of CO2. We emit a lot of CO2 during the steel manufacturing. If you put all these materials and then develop a structure and then and put the solar panel into it, and then when you do the life cycle analysis for 25 years, you will find it will not be much improvement in compared to the land-based systems also. So this is a problem. Huge metallic structure, huge cost. And we are actually also affecting the movement of the animals and movement of people. Sometimes use the canal for many purposes. Sometimes we use this canal for other purpose also. So these all get affected with the canal top system. So this also may not be fully sustainable. Then comes the floating solar system. Why floating solar system? Why? What is the reason behind it? A major reason I told about the energy demand. There will be huge energy demand, 35% demand by this one. And then there is actually a global shift towards renewable energy. Everybody is now talking about clean energy, green energy. There is always about talk on energy transition. So if you go to the literature, today everybody talks about energy transition. Due to COVID and all, people started to realize that there should be a sustainable growth, there should be a sustainable transition. All these things have become a talk now. So there is a global shift, and there is a pressure too much on developing a clean energy transition, because many of the other developed nations are actually very clean and green. So there is too much pressure on Asian countries to move towards a green energy. Hydro and wind source are very specific actually. If you talk about wind energy source, it's very restricted to a certain areas. Maybe if you go to Tamil Nadu, you can see only in Tirunelveli district or Nagarkoil or Kanyakumari district, you'll find a lot of wind farms, because there is a good amount of wind energy. The annual energy wind speed should be very high, then only it is possible. Similarly for hydro, only with dams, wherever the hydro dams are possible, they are only possible. So there is a specific site is actually reason. And PV can be installed at any favorable pace, because wherever water bodies are there, there is a possibility. There is a huge pressure on the land. Of course, this is a major actually factor. And floating can be installed on any water bodies. It doesn't matter. It can be a canal, or it can be a floating, it can be a lake. It can be a river also. It can be a dam, or any kind of water bodies, any kind of industrial ponds or industrial utilities. For example, thermal power plant, not of industrial wastewater ponds are there. So these ponds also can be accommodated. So it need not be a freshwater bodies. It can be any water bodies. And the floating PV results actually decrease in cost and increase in amount of generation. Why? Because when you talk about the land-based system, we use this concrete structure. This steel and concrete structure adds to the cost. With the help of this floating, we don't go for a metallic structure. We can go a slightly cheaper structures made up of plastic or some other material. So in that way, there is a low cost in installation. So this is one, land scarcity and land use conflicts. These are the two major force which is actually driving us towards floating solar system. And because of that, the total cost of the solar system can come down with the capex system. And there is also social rejection of projects if you use agricultural land. Especially you take our Tamil Nadu region is more about agriculture. We totally depend on agriculture. So we cannot convert all our agricultural land in Tanjore district or any other district for the solar installation, because it will affect hugely our food prices may come. So we need to plan very meticulously for the land use, especially if we want to generate energy from the land. Also, there is a slight visual impact with the ground-mounted systems, because these solar systems produce a lot of glare in the daytime. It reflects the light, and then that light reflection can cause some visual impact also. So this is one small constraint. And with the water bodies, there is no need of metallic structures, and sometimes a grid connection is actually nearby. So this is why we go for floating solar. But there are some installation conditions also. What is the installation condition? Basically, the water depth should be within 6 meters. The water level variation, even there is a huge water level variation, still can go. But so far worldwide, whatever floating solar systems, there is no major water level variation. Even in summer, it should not totally get dried also. So the maximum water level variation within the 6 meter is there, means it's actually very good. And the location should not experience water loss during very drought seasons and other conditions. And the location should not be susceptible to high waves or strong currents, especially you take about rivers and other lakes, even stagnant water bodies also. Sometimes there is a strong waves and strong currents actually, sometimes due to monsoon season and all. You can find there will be strong waves. I'm not talking about the waves in the ocean. There will be waves even in the stagnant water bodies also. So these also contributes to a problem. And location should not be risky of heavy snowfall and water freezing. This holds good if it is North India, if there are other states like Himachal Pradesh and other places where there is a huge snowfall during the winter season, and the water body is itself covered with snow. So those lakes, I think, very difficult to put the systems. It will cause a lot of damage actually. So we should find a place without risk of snowfall, without risk of water getting frozen. And these water bodies should have a very good access to the road and water line. Then it is very possible. And also at the same time, it should be near to the utility grids, because we cannot transfer power from very large distance. So hopefully the substation and other local utility, the grid connection should be very close to the site. So in that way, these are some minimum consideration for installation of the floating solar system. Coming to the whole concept, I was talking about this 6 meter variation. The 6 meter variation is, let's say this is during monsoon season, you have a water level of this much. Let's say when the water level comes down during summer, and then automatically the system should come down also. So this water level variation is roughly, if it is within 6 meter one, it is very easy. Accordingly, we can have this systems actually. In case of a floating solar system, it is nothing but installing the solar PV on the water bodies, and then extracting the power from the water surface and then transferring to the grid connection, which will be naturally on this ground. So all this electrical infrastructure will be on the land surface. Only the mechanical and the civil structure will be on the water. And of course, the cables may be inside the water, or it can be on the land. So this is how a floating concept works. Here, the major components, you can see a PV module is a very important component. What type of PV module we need to choose for water environment? This is the first factor. And then you need to think about a mooring system. A mooring system is the anchoring system, which should adjust according to the water level variation in the different seasons, during monsoon, during summer, during winter. If there is a water level variation, it should adjust itself. So mooring device is very important part. A stable floating system, irrespective of water level variation, this whole system should be stable. Even if it is a wind speed more than 150 kilometer per hour, or very high wind speed, still this system should be floating. It should not get affected in a high wind speed and all this, because sometimes cyclone, sometimes tsunami and other wind conditions are coming. So that should not affect our system. Then underwater cable. So here you see the DC power cable actually can normally goes through the underwater, and then it is transferred here, and then through the inverter we convert into AC, and then we distribute it. So this DC cabling should be perfect. It should be there are some norms for this cable also. I'll go into the detail later on. What will be the norms for this cable? What is the norms for the module, and how rigid this, how flexible should be your anchoring system coming to the seasonal variation in the water level. So these are all actually a blend of three branches of engineering. Principal said it talked about the engineering actually, because now the world is moving towards a department where we should have expertise in almost all fields of engineering. I basically coming from mechanical background, but slowly I become an electrical engineer. Now I can talk about electrical transformers, electrical power systems, stability, harmonics. I became literally an electrical engineer. And since I talk about this building systems and all, I become a civil engineer also. In that way, now the world is moving towards interdisciplinary field. I think we should have knowledge in almost in all branches of engineering. So this engineering problem, you see, there are three different problems are coming into it. Here, the structure itself is a civil engineering problem because the system should float on the surface. How to make it float on the surface? It involves buoyancy. It involves so many calculations and so many things. So this kind of anchoring system, it comes under a civil engineering background, but it comes to the subsystem of the infrastructure, electrical infrastructure, transmission, all this DC cables, this comes under electrical purview. And then coming to the mechanical structure, the steel or the floating structure of HDPE, all this mechanical structure, we only do the testing and see whether this mechanical structure is good enough to put in the water bodies or not, whether they have enough UV resistant, whether they have a good amount of strength, whether they have a good amount of mechanical strength. All these mechanical aspects actually we are doing it actually. So it's a hybrid concept. This is a complex problem in engineering which involves different branches of systems. Again, when you talk about IT sector here, now these days people talk about IoT, Internet of Things, and artificial intelligence, remote monitoring, SCADA systems. All these things will come under the IT engineers, where they will monitor this performance at the sitting at home. I can see how the plant is behaving by collecting the data. If something happens, I can do the troubleshooting by sitting at my office, or sitting at even by sitting at Malaysia, I can operate my plant in India. So that is how the world is moving towards. So this kind of artificial intelligence and all this become an IT field actually. So this is how this whole concept's actually evolving. This is a lot of challenges here. I will come to the challenges one by one now. And solar plant and water bodies here, a lot of safety issues are there because the DC cable, you see, it has to pass through the water, and even a slight leakage can put a lot of pressure on this system, and then electrical shock, then safety, fire issues, all these things can happen actually. So this is a major problem here. The safety and the engineering aspects of this, structural stability is very important. Normally solar plants, they say 25 years of life, the modules can give power, but this is about only the modules is guaranteed 25 years. How about the other systems like your anchoring system, your mechanical structure, do they have a guaranteed life of 25 years? We are not sure, because this HDPE material, the plastic material which floats on the water body, has also limited life also. And this anchoring system, which involves a civil concrete, sometimes structure and all, this also have a limited life. So combinedly, if you put all these infrastructure, the life of the system may actually less. So it needs regular repair, regular maintenance of the anchoring system and all. This will come into the picture. And mooring systems to keep the system stable. And then the PV module should be suitable for the water environment, because this module should be capable enough to work in a good environment. For example, the water body may be salty, the water body may be fresh water. We don't know what type of water body we are going to install. It depends on the salinity, it depends on the salt content, it depends on the turbidity of the water, environmental parameters of the water. Water quality plays a very important role. Let's say we put this put this solar system on a freshwater body, which is supplying drinking water to our locality, many of the people will be against this one because this solar system can affect the water quality also. So this issues also to be addressed actually. And the PV module, not only PV affecting the water affecting the technology also, because this water, if it is having high salinity, it will affect the life of the module. The module gets corroded, the module gets it becomes affected by the water also. So not only there is a two-way effect, technology affecting the environment and this environment itself affecting the technology. So both the side we need to see when you plan for these such systems. So therefore it involves a lot of engineering actually. A lot of engineering is involved. Mechanical engineers, electrical engineers, and civil engineers. All of us have to work together to come up with this viable design. Underwater cabling and connection systems, it poses a big challenge actually, because these cables should be water resistant, and this cable should be very rigid also, and it should be capable to transfer the power without losses also. All these things has to be studied. So this is the overall component. Again, I'm highlighting some of the important components here. Here you can see the PV module, the mounting structure, and then the pontoon, and then the inverter and off system, the subsystems all in the land, but only the solar and the platform is on the water body, and the cabling system can come in the water body also, and then the anchoring system and all these things. So this entire put together is a floating structure. In the case of land-based system, we use metallic structure, but here we use a very this structure need not be a metallic one. It can be a plastic, or it can be any material, as long as it does not affect the water environment. So that is a very important aspect. Floating platform, mooring system, cables, and subsystems. These all designs actually we need to do. If you, let's say I talk about a 5 megawatt floating solar system. So how to design a 5 megawatt floating solar system? We know 5 megawatt means we calculate the number of modules in strings and series. We just say 5 megawatt. That's all. It is not like that. 5 megawatt floating solar system includes this subsystems also. It includes the anchoring system. It includes the floating platform. It includes the inverters, transformers. So when I say 5 megawatt floating solar, then all these components design comes into picture. It's not just the number of modules or number of strings and number of arrays. So all these things should come into the detailed design. So detailed engineering comes into picture here. So these are the key components: floats, pontoons, mooring system, PV module, cables and connectors, and floating structures. Normally we use a HDPE. This is a simple marine. When you go to the many boating spots and all these things, you can see boats and ships are anchored on the surface. If you go to Kodaikanal water bodies and all these things, when you take this one, many of this, there will be this kind of platform on the water, because we need to walk on the water surface to reach the boat. So this material is basically a plastic, which is a high density polyethylene material, and it is UV resistant, UV coated, and it withstand the life. Actually, it can withstand the load. It can float on the water irrespective of the buoyancy. All these things should be taken care. So further, these days, a lot of other materials also being researched, because when we say plastic, then people have a problem. But plastic is not a problem. Plastic as a material is not a problem, but disposal of plastic is a problem. How do we dispose the plastic? How we use the plastic? That is only a problem here. Never see that plastic as a waste material. Plastic is actually a good material. It is the cheapest material. It is the most efficient material. But when we say plastic, then we say plastic is dangerous. It is not dangerous. It's a very useful material. It is actually cheaper than the steel. Problem is, if we don't use it properly, we don't dispose it properly, we don't recycle properly, then that is a problem actually. So we need to think in that direction, how to make use of the plastic very efficiently. So here we use normally high density polyethylene, LDP polyethylene, a lot of this one. Fortunately in India, we have a very good Central Institute of Plastic Engineering is there, SIPET in Chennai, and I think more or 5 to 6 SIPETs are there. They are doing wonderful job on coming up with the plastic technology. One of my PhD student was on the SIPET also. He's also a director there, and a lot of they have developed with a very good indigenous technology of this material, low-cost material, which can be used as a floating device. And mooring system, actually, this is a problematic one. It's a civil structure. This structure should float on the water, irrespective of the water level variation. Sometimes water level less, sometimes water level high. It should adjust itself. So your anchoring system should be flexible enough so that irrespective of the water, irrespective of the wind speed, this should float actually. This is a major problem. It should not turn, it should not fail, it should not sink. These all things should be taken care. So for that, we need to design a very good anchoring system for that. Of course, the cables and connectors, this is an electrical part of it. The DC cable and AC cabling should be proper. It should be high temperature resistant, waterproof cables, robust cables should be there. These days, I think optical fiber based cables also coming into picture. I think there are advancement in the high power transmission cables with very good international standards of being developed. And also the sizing of cable is very important. There are some numerical relations for cabling and all this, the design, because we don't want more resistance, more loss in the DC cables and AC cables. Of course, cables are more efficient. The losses are very less, but we need to try to reduce the losses in the cables. The I2R loss, I think you people may be very good in the understanding the DC cables and what kind of losses happens in the electrical transmission. So this aspect has to be taken care. These are some of the examples. You can see a lot of floating solar installations. These are taken from various sources. Coming to the PV module requirements, there are some standards which it has to meet. IP67. There are many standards are there, and it should be free from lead, and it should pass the drinking water test also. It should not create any problem on the water environment. Lead content in the system should be very less. Waterproof cables and proper sealing material also, because this PV material should not leak when it comes into contact with the water. It becomes a very big problem. So there will be a material rupture issues also there. So these all should be taken care. So we need a very highly specialized module for that. The land-based module, we cannot use it in the water-based system. So water-based system, the module have other specific requirements, which will have other test which it has to pass through. Then only it is capable enough. Today we have a technology, fortunately, Sail and Terry Hydroleo system. This is one of the French company which is a leader in the system. They have installed a lot of floating solar system. They have patented the technology, and today globally this is the only one company which is coming up with a modular system. Again, some of their systems actually have failed also. In Japan, when there was a severe tsunami and severe cyclone, actually many of the floating solar system got damaged also. Fortunately, they repaired and now the system is working. So, but again, we need to see that how these systems are taken care of, huge load, how wind load has to be taken care, all these things has to be done. So this is a patented technology which they have come up with. This is the technology they have so far. You can see here a solar module getting placed here. Let's say we have a 300 watt module and here a 300 watt module. Likewise, we can have a series of arrangements, and there will be a pathway. Actually, this pathway can be used for as a bridge to connect these two systems, and this also useful for walkway. This can be also used as a walkway, and this helps to maintain the system. This helps to float on the water surface. So in that way, the mounting structure is designed. Problem with this mounting structure is even if one panel actually fails there, it causes a problem in other systems also. So this kind of arrangement has got its own problem as well. And there is another system actually made up of ferro cement and other metallic structures also, and which is aluminum, anodized aluminum access base or there. This is by another company. They have a stainless steel pontoon straps and all. So the mounting structure actually plays a very important role. Here, a lot of challenges are there. Here we need to come up with a technology which is actually cheaper, the technology which is reliable, which is long lasting, and the technology should have a life higher than the solar PV module itself. So there lies the challenge here. So we have a very good ample opportunity research on developing a very good mounting structure which has a longer life than the PV module itself. So this is a hybrid type which involves as I talked about, the water level variation. So this system should adjust itself with water level variation. And these kind of systems are also possible, not like our this kind of structure, which is given by the Sailor and Terra company. This is by another company, which is Korean-based company. Actually, Korean and French company are the leader in this kind of platforms for developing this anchoring systems. As far as the floating structure, there are other systems also coming into picture now, which we call it as FTCC system and submerged floating solar panel. Many times the solar panel can be immersed inside the water. You take example of underwater robots. Many times we need technology to power the underwater gadgets. People are doing some research on underwater marine objects or many other systems. So for that, when you want to power those underwater gadgets, we can think about submerged solar PV systems where the solar panel can be slightly inside the water also, slightly inside the water. This is called submerged system. But this submerged system uses a special technology called thin film technology. And this thin film, maybe it can get immersed inside the water and still produces electricity. And this electricity can be used for other applications for underwater gadgets, robotics, and all these purposes it can be used. And this one is actually a combination of tracking and concentration. You can see a lot of mirrors actually placed, and these mirrors actually helps to concentrate the light on the solar panel. At the same time, it uses a tracking system, which is actually another company has developed it's Italian-based technology. They have come up with this concentrating cum cooling systems where it is supported by a raft. And then there is a submerged systems which actually used for improvement in efficiency and all. And also there is a lot of advancement in marine environment. So far, whatever I talked is about the water surface, which is not for the marine condition. That is for a normal water bodies. We have a lot of water bodies, Mettur Dam, you can say other reservoirs in Tamil Nadu can be used. But there are also ocean, water environment, especially marine environment can be used. So if you go to the east coast from Chennai until Kanyakumari, it's all coastal area. So we have a large coastal region. If we could use this coastal water bodies for power generation, I think it will completely meet our energy demand. There need not be any other additional thermal power plants or nuclear power plants getting added. So this one is good enough to power our systems. Problem again is marine water is too harsh. People living in Kadalur and other parts of India, they will be afraid of tsunami and other effect, because tsunami and all very dangerous thing, and this technology can easily fail in the marine environment, because in marine environment lot of safety, lot of other features are very much needed, because it is prone to wind, it is prone to wave, it is prone to salt water condition. Lot of challenges, because wind is a challenge, wave is a challenge, salt water is a challenge. We don't know what the load actually keeps on varying as the waves rise and fall. There will be a lot of load variation on the whole anchoring systems and all. So that become a big problem for this kind of system. So therefore, the cost of the system is going to increase, because we need to have a very good floating solar system which will withstand the marine loads. Marine loads are different from the freshwater loads. Freshwater load is actually only wind will come into picture. The wave will not be much wave is not there in the freshwater surface. So this is another problem. And also in the case of marine environment, lot of aquatic organisms are there. You can say fish or many even harmful aquatic organisms are there. But in the case of freshwater, it's normal fish and algae and other things are only available in the normal surface. So the marine surface poses a lot of challenges. It involves a vertical load, it involves horizontal load, it involves so many safety issues in the marine environment. This is a core technology. The more marine environment, we need to develop a salt-resistant PV material. So that is a major challenge. And this floating structure should withstand the high waves, tsunami, and typhoon. This is a challenge actually. And also the depth of water, the geology of the water surface, this all comes into picture here. And the transmission system, which involves long distance transmission, and the cable stress also, because we put this marine environment, we don't put on the very close to the to the beaches. We go into the deep ocean and then we have this kind of structure, because there the wave and tide is very calm. Whereas you go to the very beach and land one, there is a big problem. So the transmission of the cables from the center of the ocean to the land, that also to be taken care. So long distance transmission, there will be a lot of stress on the cable system. There will be stress on the electrical infrastructure and all these things. And since this module actually undergoes a lot of vibration, lot of movements, and these movements can lead to salinity. It can lead to cracking of the solar modules. It leads to micro cracking, and this micro cracking will reduce the life of the solar panel. So this is a problem with the marine environment systems. What are the advantages? What are the unique features? Actually, it saves a lot of land, because in a land-based system, 1 megawatt need 5 acres. So if you use water, I think literally we don't use any land actually. And good amount of water conservation, water evaporation, because roughly 9 million liters of water per megawatt per year can be saved. There will be a clean and green energy. Lot of CO2 can be mitigated. And also this water helps in keeping the solar panel cool, and this improves the efficiency and the yield also. And there is a reduction in the transmission and distribution losses, because if we have closer to the grid, it can contribute to the strengthening of the grid also. And this project can be integrated with the hydro project, thereby we can increase the electrical power generation capacity of the hydro plants. So this way we have several advantages of land conservation, efficiency improvement. There is a new market trend actually, because we are moving from the land-based system to the water-based system. So indirectly we are creating a new market, new job opportunities, new job creation, especially in rural areas, because many of the water bodies are in the villages actually. If you go to many of our states, a lot of water bodies is all in the rural areas. So a lot of job creation and improving the rural infrastructure is possible. Also, you talk about the small island nations. Example, Lakshadweep Islands in India, then Sundarban Islands in West Bengal, and then other island countries, Singapore and many other island countries, they have land constraint. Land is huge, super cost, super expensive. We cannot own a land in these island nations or these island countries, because they have a very expensive land actually. For these island nations, floating solar is the only solution they have. This is the only solution, only sustainable solution for the island nations and all. It creates a lot of opportunities for them. Local jobs can be created. Very good sustainable solutions are possible. Other specific advantages, less amount of algae formation. There is no algal growth. Pros and cons both are there. Algae formation is good also. At the same time, it affects the algal growth is also a problem, because we don't want algae to die also. It should also live, and we should also get some benefit from the water bodies. So basically we need to balance the growth of algae. Also, the growth of the algae should not affect the growth of the technology also. So we need to keep balance of this thing. Since there is no foundational work, then the deployment of PV module on the water environment may be slightly easier than the land-based system, because we don't need foundation, we don't need structure, we just need a floating platform. So here the foundation is replaced by a floating structure, and it can contribute to the local power generation, and it can contribute to many other this one. But there are design challenges. One by one I'll tell you. In many of the Indian reservoirs, the water level is actually changes like anything. Take an example of reservoirs in Mettur or in some other Kaveri Dam and all these things. So these water level actually varies from summer and rainy season. So this poses a very significant threat. Actually, we cannot rely on these water bodies. Then there is a huge water level variation. We need to come up with a technology which is suitable so that the anchoring system, even if there is no water, it should be fixed on the land surface, something like that. So this anchoring system should be stable enough that if there is no water in the water bodies, then it should sit on the land itself. So something like that. So this is a design challenges. Then there is a flash floods that it involves a careful mooring and anchoring system so that there will be no panel damage, micro cracks. Then aquatic life and other activities also should be taken care. Some more environmental constraints also. The strong winds is a problem. Flash floods, this I think we need to take care of the aquatic life also. Marine organisms should not be affected. Fishing should not be affected. Recreational activities should not be affected. Actually, problem here is many of us would like to visit the dam for other activities like recreation and all these things, boating and all these things, boating, fishing. These all activities should not be affected also. So we need to balance all these things, balance the environmental effect, balance our societal needs. The social acceptance is very much needed also. So hereafter, when we talk about a technology, we need to think in terms of all the aspects, not just the technical aspect, not the economic aspects. Technical aspect is very important, but the economic aspect, cost-wise, many of the companies will be worried about the cost. Environmentally also we should be worried. How good it is, how safe it is to the environment, how good it is to the ecosystem, all these aspects. So technical, economical, environmental and social. So all the four aspects of the technology should be considered when you design a system. So as an engineer, as a technologist, when you design a system, see to that we take care of four aspects: technical aspects, environmental aspects, economic aspects and social aspects. Then only we can prove that the technology is viable, because we have learned a lot of lessons from so many projects installed in Tamil Nadu or any other controversial sites. A lot of I see oil and gas projects. I see a lot of nuclear projects facing a lot of problems from the local authorities, from the local people and all. These are all sensitive issues. So that's why, as an engineer, we need to plan the system such that we take care of all these things, environmental concerns properly, and we address all these environmental concerns, and then we propose the projects. So all these things should be equally considered when you plan for systems. And then it also involves so many other things, policies actually, because many of the state will have a different policies, and sometimes the policy doesn't work because of bureaucracy and all these things. Globally, this is a problem. It doesn't, especially in Asian country, the policies are there, but implementing the policy and implementing it correctly, they become a problem. And also there is no supportive policy for floating solar in some countries. Asian countries got, but there are maybe some other island countries and all, maybe there is a problem. There is a long, complicated permitting process because we need to take a permission from the environmental board and then permission from many other authorities. So these are all challenges, this to be addressed. And even fossil fuel, till today, there are a lot of subsidies for fossil fuel plants and all these things. The social, economic and political pressure is always there. So this also contributes to the barriers of the technology. Coming to the applications, we can go for dams, we can go for lakes, reservoirs, we can also go for irrigation ponds, industrial ponds. Actually, many of the industries have already wastewater treatment plants, textile industry, paper industry, many other harmful chemical industry, they always have some wastewater ponds. These wastewater ponds also can be used for the installation. And recreational ponds in Ooty, Kodaikanal, you'll see a lot of recreational spots. These recreational spots can be used. A lot of water bodies have application. There are, I think I didn't update this slide, a lot of advancement in the technologies. Large scale, megawatt scale plant has already come in the floating solar system. Slowly, there is a very good, tremendous growth in the PV system. Let me play a quick video on the floating solar. We'll understand the whole concept. So this is taken from other resource. They are more efficient than the water system. This is the floating systems actually on a pond. You can see the structure. You can see the arrangement, how it is being connected. They actually follow some shape, square shape, rectangular shape, circular shape. This is contributing to the stability. Stability also, it cools the panel. It improves the efficiency. These are all now built in megawatt scale. Actually, you can see the DC cable, how the cabling is done. It actually comes through the water surface, you can see. And this can contribute to the lot of energy generation and clean energy. Lot of households, if it is island nation, all the households can be powered. A lot of advantages are there. Also, the floating material, what they use, actually, they say 100% recyclable. After 21 years of its life, this all components can be recycled. And these systems are capable to withstand storms and typhoons, they say. And this is a Japanese company, they have come up with the technology. So the problem is with so many aspects. I covered all these things. And economic and social benefits, we should consider no deforestation, because we are not using the land actually. So indirectly, we are saving our land, which improves the other things. It also contributes to the aquaculture, because sometimes the fish and other things likes to breed in the beneath the floating systems actually. So this also indirectly contributes to the breeding of the fish farms. Aquaculture indirectly is getting promoted also. And high energy yield water surface is being used properly. Water evaporation is there. Greening of the system, because we don't cut the trees, we don't destroy the ecosystem. Land is actually saved. A lot of environmental benefits is there. Future work, I think we need to think about coming up, reducing the cost of the system, and then good, cheaper, economical mooring system. Also reducing the cost of the underwater cable. This is the challenges we face. We need to come up with the cheaper technology for this. And problem here is there is no safety and standard protocol actually. So we need to come up with international standards. What is the international standards for solar PV module? What is the standards for the subsystem electrical infrastructure, cables, connectors, all these things. And then also safety precautions, what are the things to be taken care? And what are the acceptability and legal issues? These all to be taken care in these systems. Environmental aspects, these all water quality, light reflection, temperature, humidity plays a role. Higher temperature, higher humidity also affects phytoplankton and noise, odor, reduction of algae growth. All this analysis has to be done. And some case studies, I'll just quickly go into some 4 or 5 slides only. Some case studies from other countries. Japan is actually a small country with a lot of, it's basically ocean-based country. They have land constraints. And I hear that rural Japan is getting emptied. So even they are selling the houses for $100, their houses. Cheap, $100. Many of the people are moving towards cities, and many of the villages are uninhabited, and a lot of problems they have. And for them, they realized that they closed the nuclear power plant. They closed all the nuclear power plant. Now they are totally moving towards sustainable systems. So this is a case study from Japan, where they are going for totally floating solar-based systems. And case study from Kerala, actually Wayanad district, they have a 500 kilowatt systems. This is a case study from Korea. And case study from Kerala, why? Because they have only water bodies, they have no other options. Land is a big expensive there, and there is a good government policy in Kerala state in India. So they have a lot of 44 rivers, 27 backwaters, 7 lagoons. Roughly 40% of their area is only water. So there is a big lake in Kerala which is having 200 square meter of area, 81 dams in Kerala. And there is it's a famous international tourist spot. I think most of us know that. So they have a very good potential, abundant water body. They have another problem is 70% of the electricity is coming from the grid. Only 30% they produce internally. And this is the first of such plant, 500 kilowatt plant, which was installed. They have a very good solar target, that is 1000 megawatt by 2022. They got a political support also. And they learned the lesson from the Japan disaster. And Singapore, there is a wonderful test bed already. This is already operational. They come up with a lot of field data, and now a lot of papers are getting published on the long-term performance actually. Previously, we don't have long-term performance data. Now these plants are already operational for more than 5 years. So we have very good amount of data coming from there. And now it seems the technology is proven. Technology is very good. It's working. It's efficient than the land-based system. There is a proven that it is very popular actually, based on the Singapore case study. And there are case studies from Korea. I showed you. They're also number 1 to install different systems. You can see like a hexagonal systems and all this thing. And a case study from Indonesia also. Indonesia also an island nation. They have only islands, so there is also very good prospects in Indonesia also. And global status, now people are going on a large scale floating solar project, because the larger the size, cost comes down. So mostly people go for a megawatt scale floating solar project. Lot of projects already come up, and small scale projects actually very less. Slowly people are talking in terms of megawatt scale. And China, Japan, Taiwan, Korea, all these things are leader. And India already started, some few projects are already in operational in the floating solar system. Performance, how to measure the performance? You need to find out the capacity, how much you can install in a water body, and you can find out what is the generation by finding out the capacity utilization factor and the annual operating hours. And you can also find out what is the water savings from the plant. In that way, we can see whether the plant is good enough or not by using this performance indicators. Last slide, actually recommendations. Actually, we need to come up with the suitable policies. We need to come up with the complete guidelines for the installation of the solar technologies. And the local governing bodies should support us in local municipalities, and the state electricity board should help in the grid access issues. And lack of awareness and skill, we need to skill the people on the technology, on the installation, commissioning, and the expansion of the national power grid also can contribute to it. And we need to exchange our knowledge, exchange our expertise in this field. And there should be an economic incentives also, policy instruments, and all these things can contribute to the much better development of the technologies. These are some of my current area of research on solar, wind, biomass, and chemical and carbon capture, artificial photosynthesis, green building, vertical axis turbine, horizontal axis. This is all basically I work on techno-economical assessment. Now I'm going towards the social aspects, environmental aspects of the technology, and then fundamental research, technology development, and finally industrial application. So we are actually looking on these two aspects only, fundamental research and technological development. So far, our technology has not led to industrial applications. So we do mostly on the techno-economic viability studies and the other aspects. So if you would like to follow me on many things, this is my WhatsApp contact, my email. You want to search me on Google, simply search Sudhakar space Kumaraswamy. You will find my profile. You will get my Google Scholar profile, Publon profile, LinkedIn profile. And you want to contact me for master's and PhD and even a short-term internship opportunity. You want to continue your master's or PhD after your undergraduate from your college, you are most welcome. And faculties who are listening to me, I think I'm open for research collaboration. I'm also open for joint supervision of your PhD students or master students or undergraduate students. Also as a thesis examiners and all. So in that way, there are a lot of opportunities for collaboration. I'm actually open for all the things. So that's all from my side. I am very thankful for the participants who are patiently listening to me. And if at all you have any queries, I'll be more than happy to share my knowledge. Thank you. I pass on the session to the organizers. Thank you, one and all.
Thank you, sir, for the wonderful session. We had a wonderful insight regarding the topic, sir. Thank you so much.
Thank you, ma'am. Thank you.
Any questions from the participants?
Ma'am, there are questions posted in the chat box. Maybe you can read out for him.
Yes, ma'am. So Arnachalam sir had posted, can we have any visuals for floating solar PV? So hopefully we had seen many visuals.
Yeah, I think a lot of visuals are there, ma'am. I just try to show only one of the visuals. If you just Google in YouTube or something, slowly now the technology is known to the people. They have a field experience, and now there are a lot of learning experience from Japan and other case studies. I think we can make use of these resources and plan for the technologies for our country also. I think that is there for the visuals. I think we can get a lot of open resources started to come actually.
Yes, sir. The next question is from Aravind. Any comments on efficiency variation of PV panels with change of shape from rectangular to any other?
Yeah, it's very interesting question. As far as the floating solar system, they say roughly, literature says that 5 to 10% improvement in efficiency compared to the land-based system. And that is only based on two case studies. One is coming from Singapore, other one coming from Norway, actually. So one was in tropical region, the other one was in another climatic condition, which is temperate climatic condition. So from these two climatic conditions, they show there is a performance improvement around 5 to 10% is what they say. And regarding the question about the type of structure, I think the type of shape actually plays a very important role in the stability of the system. So normally they say you want a hexagonal structure or a rectangular structure. This all helps in more stability of the system. But indirectly, how much this contributes to the performance improvement has to be studied. It's a very wonderful research topic to be studied, how the shape and orientation of the structure improves the performance of the floating solar system. That would make an interesting study. But I feel when it comes to the heat transfer perspective, we need to see that there should be a gap between each arrays of solar panels. So thereby the humidity temperature effect to some extent should be reduced. And if this temperature factor and the humidity factor is controlled, then naturally it will contribute to the better efficiency improvement. So this is what I can say now, but further research may be needed when you want to compare the shape of the system.
Sure, sir. The next question is from Tanjavur Subbarao. What is the maximum capacity of floating solar PV?
Yes, sir. It's a very interesting question. Again, it depends on the water surface and water area availability. The literature says that the floating capacity need not be, should not cover the entire water body. Actually, they say only 30 to 40% of the water body only can be covered. Rest of the water body, 60% of the water body should be left as it is, because it should be used for other activities like recreation, fishing, boating, and all these things. So 30 to 40% is a suitable area which can be covered. As I said, it depends on the water reservoir area. 1 megawatt we want to install, roughly we need 5 acres of land. So roughly similar water surface is needed, but how closely we arrange, what shape we arrange, depending on that, the capacity will differ. Depending on the area availability in the water bodies and depending on the design, this will vary, sir. It can go even megawatt range, it can even go to the gigawatt range. So if you have a very big water reservoir, dams or hydropower plants or oceans, I think size doesn't matter here. We can go to a very large scale. Also, we can go to a very small scale. But ideally, they say 30 to 40% of the water only should be used. We cannot cover the entire water body with the solar. So that will affect the environmental sustainability will be affected actually.
Sir?
Yes.
What is the preferable material for floating solar PV system, whether it is dye-synthesized or Ferrous Kite or organic solar cell or silica based, sir? What?
Yeah, that is a good question. Actually, so far, for the commercially, we have only crystalline technology, ma'am. We don't have the organic or thin film based technology commercially available. There are some few companies which have come up with the thin film technology for building applications. But again, these technologies, the long-term performance actually has to be tested in the water environment. So far, whatever the technology which we are seeing in the world, especially case studies from Japan and other countries, even from Kerala and other states, actually, it's all about polycrystalline technology. So thin film, carbon-based, dye-synthesized perovskites, actually, since we don't have experience with these PV modules, and these modules also not experimented in the water body so far. But again, this is all in the initial stage of research, and this has to be tested. That's why you can give a lot of projects to your students and study this in the lab scale. For example, you can create a small water surface and then put this thin film or other technologies and study the effect of this on power generation. You can study simply the voltage current characteristics. You can simply study the power output and all these things. Based on these small scale lab experiments, I think we can come up with some comparison between all this technology. So far, we don't have, ma'am, regarding the application of these thin films and all. But I think one or a couple of thin films actually I saw on being used on the water bodies for submerged systems and all. I think Professor Rosa from Italy has done a lot of work on thin film technologies on this one. But slowly, I think this technology will become popular in the coming years. But so far, crystalline is only being used for water bodies also.
So similarly, what is the simulation that you have used for this floating PV system, sir? Simulation studies?
Yes, ma'am. Coming to the simulation part of it, we have a lot of equations for the performance assessment. It's like you go to the PV simulation or any software simulation like PV watts or PVJs or any software simulation. We just give the capacity of the system and we give the sunlight availability at the given location. Then naturally we will get the amount of energy generation and all. So basically, what we can model here is the amount of energy output from the floating solar system can be modeled, provided you know the water body location, whether the water body location is in which place, what is its latitude, longitude. By knowing its location, we can model the energy output from the system. We can model the temperature of the module also, how much temperature the module can be cooled when compared to the land-based system. So that can be modeled. Even with the MATLAB modeling, we can do this by writing M codes and all. The energy generation can be modeled. The temperature effect can be modeled. We can also model the electrical performance. We can model the thermal performance. We can model the energy efficiency also. All these things actually can be modeled. Then water loss, water evaporation, how it can be minimized. All these things can be modeled and built in a MATLAB or built in an Excel sheet, and we can analyze the performance for a small scale system. Simulation also we can do. Given the location of the water reservoir, we can do all this analysis.
Thank you, sir.
Sir, a few more questions are posted in the YouTube.
Yeah, ma'am, please.
I shall read that also, sir.
Yeah, please.
A question from Kartika ma'am. Procedure to clean the solar panels due to environmental conditions.
Yeah, ma'am. Actually, this cleaning and other things is a big problem in floating also. Actually, the water bodies, they are very good because water is available, we can go for cleaning. But there is actually a lot of problem in the cleaning there. Why? Because birds, they use this water bodies to rest on that. Bird droppings on the water bodies are very much higher than the land bodies. That's what the experience from Singapore plant actually. Many of the birds, migratory birds, they actually come to the water bodies. They do the nesting, they do put a lot of bird droppings on the panel surface and becoming hotspots, and cleaning and cooling becoming a big issue. So these days I saw robotic based cleaning systems. They use drones and they use some advanced cleaning technologies. Even the bird repellent system, they keep some warning system or alarm system so that bird doesn't come on the water bodies. So such systems or such advancements also coming. I think which is non-contact type of cleaning, especially water sprinkling arrangement, all these things which are operated by drones or other sensor-based technologies, that would be actually suitable for floating solar. Whereas in the land-based, actually they go for manual cleaning and vacuum cleaning and all these things. But for water bodies, I think since they put a lot of money into it, I think they can go for advanced cooling systems and cleaning systems for this.
Yes, sir. The next question is from Duraivel, sir. What are the subsidy given by our government to install solar panels for the purpose of home utility?
Yeah, I think this policy actually changing from state to state, ma'am. So for past 4 years, actually, I'm out of country. I am still not very much clear with the state policies of our country. Now I'm closely watching with the Malaysian policies, how it's favorable. They have very good policies with net metering systems and all. Now here picking up actually in Malaysia, this building-based solar systems are picking up. But in our country, I think slowly the state-wise policy depends actually on the political will, and then how much the government actually supports and how much subsidies are given. This varies from state to state. I need to see the current guidelines, current policies of the government. I hope there is a change in government with a lot of new things may come. I think Tamil Nadu Energy Development Agency TEDA website, you can go through the latest policies related to the rooftop-based solar systems and subsidies permissible. I hope at least 10 to 20% subsidies they may give, but I am not very clear with the current policies of our government.
Yes, sir. The next question from Manikandan, sir. Will it affect the aquatic organisms?
This is a very controversial topic also. It is actually affecting because it is having both plus and minus. Many of the research, they say it is contributing to the shadow and algae is not growing. So this is one argument. The other argument is actually, it is actually favoring because many of the fishes and other aquatic organisms can breed beneath the floating platforms, and thereby there is an enhanced fish production, there is an enhanced aquaculture production. All is possible, they are saying. At the same time, they say if these plastics are all damaged and these components are damaged, this can affect the water quality, it can affect the turbidity. If it is a freshwater surface, it may affect even the water quality, they say. So this needs detailed assessment. As of now, the assessment is still unclear actually. 50% they say less impact, 50% they say there is a favorable impact. So long-term impact has to be studied environmentally. So this may lead to slightly very unclear about the technology aspect. But technology is showing the positive impact on the environment. But I put that limit of 30-40% of the coverage. So that will take care of all this environmental effects. But if we use extensively the water body, then there will be definitely environmental impacts, sir. We don't use full of the water body. We just use 30 to 40%. Then I think to some extent we can manage the environmental impact to a lesser extent.
Yes, sir. The next question is from Narmada Madam. Sir, can this project be implemented along with wave energy conversion systems if it is erected on oceans?
Yeah, wonderful question, ma'am. Actually, this is what happening now. You can read one of my papers on hybrid floating solar designs review. There we are actually talking about floating solar with various combinations. Floating solar with the ocean, floating solar with the wind, floating solar with wave energy, floating solar with hydrogen energy, floating solar with desalination plus wave generation. Lot of conceptual designs actually there, because in Tamil Nadu, a lot of problem with regard to ocean water, drinking water supply. So when we have this floating solar system on the ocean, when we include the wave systems also into it, wave system plus floating system plus desalination. This will be a very, very attractive concepts for island nations and all, Lakshadweep and other island nations. It will be a wonderful technology development if we can come up with these kind of solutions actually. But these are all in the initial stage of development. Concepts are existing. What you suggested, the wave energy converter plus floating, is all conceptually existing. But the detailed engineering, detailed performance assessment and all these things is still lagging. I think we should all contribute to the development of the technology as a whole. There lies our contribution in this sector.
Yes, sir. The next question is from Dr. Sandana Krishnan, sir. Is concentric PV panel technology gives reasonable challenges?
Yeah, concentrators, sir, actually in some Western countries, they don't have good amount of sunlight and temperature. We all know that the solar PV performance is optimum at 25-degree operating temperature. That is called standard testing condition. But in our tropical region, the temperature is too hot. 40-degree will be the ambient temperature. So the module, the panel temperature can reach even close to 50-60 degree centigrade in the hot sunny condition. So in water environment, we try to maintain the temperature close to the standard operating condition of 25 degrees with the help of cooling, natural cooling. That is called natural convection. But in some countries where there is no sunlight and where there is no good amount of sunlight falling on it, they need to concentrate the light. So some of the European countries, Italian and all this, they come up with the concentrator systems. They concentrate the sunlight on the solar panel and then they try to maximize the power output. So that such case studies are available, but that may not be the requirement in our context. In our tropical regions, we don't need concentrating the sunlight. Concentrating the light is needed for thermal power aspects of generation. So the example which I proposed is for other countries actually. For ours, I think we can just go for a normal PV with proper cooling and cleaning arrangement should work for our condition.
Yes, sir. The next question is from Vishwanathan Ganesh, sir. Thoughts on implementation of carbon nanotubes for conducting in PV panels? What is stopping us from having CNT in PV?
Yeah, there's all actually lot of new developments are taking place. Carbon nanotubes, Ferrous based solar cells, and all. Lot of articles. Actually, these all involve fundamental research. So our science people are very good in that. Actually, they are coming up with a novel material. They are coming up with a novel material showing that these technologies are suitable for PV generation. But again, we need to make use of these materials to come up with a commercial solution. So there lies the gap between the science-based knowledge of performance enhancement and all these things, and converting that science-based ideas into industrial systems of industrial technology-based one. I think industry is slowly realizing that now industry academic type is coming, and then slowly these carbon nanotubes or whatever the new solar PV technologies can be a future. They can substitute the conventional technology of polycrystalline and all. Hopefully, you can see some change on this. But as far as CNT as a material, if it is coming from pure carbon-based substrate, and if it is not causing any environmental impact, and if it is locally available, and if it is proven that the efficiency is much better than the commercial PV technology, more than 15%, I think there is a possibility. But I see it will take some time, maybe another 5-10 years or so, we may find these technologies to be commercially viable in the years to come.
Yes, sir. Another similar question from Shishir Bopanna. What about the infrastructure and anchor for material for support?
That is the major challenge. As I pointed out, the whole problem is only with the anchoring and the mooring system. So in the floating solar system, material part is very clear. We are very good with that. HDP material, all these materials are available, which is proven. Electrical subsystems are all very clear. Inverter, all advancement, all cables, all we have advancements. Only with the anchoring design, how good your infrastructure, the civil infrastructure should withstand the load, both the water load as well as the wind load. The wave load should be taken care. High cyclone, wind speed, and then water level variation should be taken care. So this is the major engineering challenge in the floating solar system, I would say, because the system should float irrespective of the water level variation. The system should be floating irrespective of the change in the wind movement and wave movement all. So I feel a lot of proper design of the anchoring system, mooring system is needed from the structural point of view. There's a lot of work to be done by civil engineers on floating solar also, because they can contribute to a better design of the structures.
Yes, sir. The next question is from Sam Kingsley, sir. Any suggested method to overcome rooftop installation? That is air gap.
Yeah. I think rooftop systems, sir, I think we need to go for thin film technology. What I understand now is slowly the people moving towards building integrated system. I think many of you would have started hearing about BIPV and solar roof tiles and all. I think the future of building is we need not have a solar panel separately. In future, I think the building material itself will be part of solar. That's what I feel in another few years. So if we come up with a technology, it will act as a building material itself, solar roof tiles and solar shingles and these systems. This building material can be replaced with the solar PV material. So if we come up with that technology, I think that will be the future than our rooftop based integration. Maybe in another 5-10 years, I think future buildings all will be only with our thin film or only with our building integrated PV systems or roof tile systems will be there. We may not have other buildings at all in the coming years. Yes.
Sir, another question from Shiva Kumar, sir. Currently, where are we using the system?
Yeah, a lot of plants are already existing, Shiva sir. Actually, worldwide, I gave an example of Japan, Korea, in India also a lot of projects. In MP, in Madhya Pradesh, lot of dams already started to install. Kerala, lot of projects coming. I'm not sure about Tamil Nadu, 1 or 2 examples are there or not. But I think already a lot of case studies, West Bengal also a lot of projects also coming. And big projects also started to come. A lot of tendering has been done for big projects. In another 5 years of time, the land-based solar will be replaced by the floating solar. I feel there will be a tremendous growth in the floating solar system in our country. I think there is a chance. A lot of case studies, lot